Hello everyone, welcome to a new video on electric vehicles technology. In today's video, we are going to discuss about battery management systems under the unit energy storage systems. First, let's get into the topic. Why we need an energy management system in electric vehicles? The main challenge here is the balancing energy consumptions. As we know, the electric vehicles run with electric power. We need to have a energy management system wherein which we need to manage how this electric power is being consumed by various parts of an electric vehicle. So balancing energy consumption and balancing its performance and having a track on its range are quite a tedious process in EVs. So hence, we need an energy management system in order to enhance the battery life and also to improve the vehicle efficiency and to reduce the environmental impact created by the EVs. So now let's see what is a battery management system, and this is the flowchart of the battery management system, how the BMS works. So first we have a speed controller which senses the speed and torque, and that is given as an input to the battery management system which has a supervisory controller and an energy management system. So together they are called as HEV controller. So the speed which is given to the supervisory controller will now decide what type of mode needs to be selected. For example, if you take an Ola EV, if the speed is beyond 40, it will be in high speed mode, and if it is between below 40, it is in eco mode. So based on the driver's speed range, it will select the mode and it will maintain the speed range between that mode. And now that mode selection is given to the energy management system, and the energy management system will supply the required power for that mode. So that is power split, and that power is given as an input to powertrain, and that will drive the vehicle. And again, from that vehicle speed, the speed is calculated by the speed controller, and this flowchart and this process will continue. And from the powertrain, the state of charge, the speed, our speed generated, and the speed, the power with the during the regenerative braking, everything will be given as an input again to the HEV controllers. So this is the general flow diagram of a BMS in an EV powertrain. So we have fuel tank, battery motor, battery power. So here I have given two inputs, which is fuel tank and also a power battery. Here the given architecture is for an hybrid electric vehicles, and that is why we have both fuel tank and also a battery power. So the power from either the fuel tank or through the battery is given to the drive gear and to the drive vehicles, and the power from the battery is given to the motor and to the drive gear and to drive the vehicles. The main objective of the electric energy management system is to maximize the driving range. So this energy management system optimizes the energy usage by various parts of the electric vehicles, because the main source of the main driving source for an EV is the electric power. Hence this electric power is being optimized in various cases, that is being ensured with the help of the electric management system, and it ensures to optimize battery life and health by proper energy management. So hence we can extend the battery life. And also the energy management system ensures safety and thermal stability. It constantly monitors the battery health and also the battery heat. So thereby it maintains thermal stability, and also it enhances the driving performance. And through this EMS we can easily integrate with renewable energy sources also. So the key EMS strategies are two things. One is battery energy management system, which is BEMS, and the other one is regenerative braking. So in battery management system, three main parameters are being managed or supervised. One is the state of charge, and the other one is state of health, and finally the thermal management of the batteries. And during regenerative braking, this EMS will constantly monitors and captures the kinetic energy during braking, and it converts back to electrical energy stored in the battery. So thereby we can generate a feasible amount of power from the regenerative braking mode. So also it provides thermal management by maintaining optimal temperature for battery and power electronics. So the key strategies for this thermal management include liquid cooling, air cooling, and phase change materials. And finally, it ensures eco driving modes. That is what I have discussed in the beginning of the slide. So in eco mode, it prioritizes efficiency over performance, because in eco mode the speed will reduce, thereby there may be a probability for reducing the chances because the output will get reduced. In sport mode, it prioritizes performance over efficiency, so thereby it analyzes the mode based on the driver's mode. Now let's see what are the advanced energy management technologies available. So we have the current trend is the incorporation of AI in every field. So here in energy management technology also we have incorporated artificial intelligence and machine learning in order to predict the energy management based on the driving patterns, and also for a real-time energy optimization. And also a recent topic which is very much under research is the vehicle to grid technology, V2G, wherein which the electric vehicles act as an energy storage for the grid. As we know, we have a number of options for producing power, but we have less options for storing the energy. And now with a wide usage of EV, we can use EVs as an energy storage place for this power, surplus power generated. And also V2G ensures bidirectional energy flow between vehicle and grid. And also finally, a new technology that is being under research is the smart energy management system, which incorporates home energy systems and renewable energy sources. So this is the quite overview of this energy management system, how it manages energy by constantly monitoring all the parts of the EV. So we have energy sources, power electronic converters, and chargers, loads, grid, everything that is being connected to the EMS, wherein which it constantly monitors everything and finally gives this solution. So the energy management system for hybrid electric vehicles is of two category. One is rule based, the other one is optimization based. In rule based, we have two categories. One is deterministic rule based control strategy, and the other one is fuzzy logic based. In optimization based control strategy, we have global optimization strategy and instantaneous optimization strategy. So, what is AI and machine learning for energy management? So, it provides a smarter energy management with AI. So, it is given with data sources like GPS data, driving patterns, battery state, and external conditions, which will act as an input for the AI. And through these data, it will process and finally gives the output. And from these, we can have a predictive maintenance, and also we may get to know about the adaptive energy optimizations based on the driving behavior, and it provides real-time route optimization for maximum efficiency. So now let's look about the future trends in energy management. We have wireless charging. As of now, we have wireless chargings, but for static, when the vehicle is in static conditions. So now we are looking for options like dynamic charging while the vehicle is in motion, and also solid state batteries, which provides high energy density and faster charging, and also integration with smart grids, thereby providing an intelligent load balancing and energy distributions, and finally energy harvesting from solar panels and other sources for auxiliary powers, which is solar powered EV vehicles are now a future trend. So through this energy management system, we can ensure EV performance, efficiency, and sustainability. And with the incorporation of advanced technologies like AI, regenerative braking, and thermal management, we can reshape the industry, and also we can spread the EV to a maximum extent to the customers. And also, these continued innovations will drive the future for electric mobility. So, with this, we conclude with the energy management systems. So we have seen about what is energy management and how this energy management works through a flow chart, and we have seen a block diagram with how this EMS is connected to various parts of an EV, and finally we have seen about what are the future trends in EV. So thanks for listening.